Hello, in this lecture I will answer two questions. In the first question, we find out the radius of this circle, and in the second question, we find out the area of this semicircle APQB. So we start with the first question. In the drawing, we have a circle. This is 97 CP. Is equals to 12 units in its length. This is 97 AP. This is equals to 4 units in its length. This is 97 PB. This is equals to 4 units in its length. This is angle CPB. This is equals to 60 degrees inside. Again, our task is to find out the radius of this circle. So, first of all, it is given us the question that AB is the straight line. AB is the straight line, so if you focus on the upper side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles from one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have this angle is equal to 60 degrees in size, plus this missing angle, so the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 120 degrees in its size. In the next step, we'll join points A and C together by a straight line. And we join points B and C together by a straight line. So, by doing those constructions, we can create here three triangles. The first triangle is the green triangle CPA. The second triangle is the white triangle CPB, and the third triangle is triangle ABC that consists of those two smaller triangles. So in the next step, we will implement the law of cosines on all those three triangles. So we start, repeat briefly on the law of cosines. The law of cosines is true in any circle. The law of cosines is true in any triangle. This is triangle ABC, that could be any triangle. This is angle BAC. This is equals to 30 degrees in size according to our definition. Side AB equals to A units in its length. Side AC equals to B units in its length. Side BC equals to C units in its length. And according to the law of cosines, that is true in any triangle. This is triangle ABC that could be any triangle. This triangle ABC, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So in the first step, we implement the law of cosines. This green triangle, triangle CAP. So, triangle CAP according to the law of cosines, the following equation is true. We choose angle theta as this angle APC, is equals to 120 degrees in size. So in this green triangle CAP, according to the law of cosines, the following equation is true. CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. Okay, again, in this we can write CAP according to the law of cosines. The following equation is true. CA squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave it as it is, so it is CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9. Plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. Minus 2 times AP is 3, times PC is 12, times cosine 120 degrees. Times cosine 120 degrees. Cosine 120 degrees is minus 1 half. So if you found out that CA squared equals to 9 plus 144 is 153. Here we have minus times minus is plus, so this expression is a positive expression. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So this expression in total equals to 3 times 12, that is 36, plus 36. So CA squared equals to 153 plus 36. 153 plus 36 is 189. CA squared equals to 189. Here we take out all of this equation and get that CA equals to the square root of 189 units in its length. This is the missing sign CA. This is equals to the square root of 189 units in its length. And CA squared equals to 189. Likewise, we will implement the law of cosines on this right angle, triangle CPB. On this right triangle CPB, we'll choose angle theta as this angle, angle CPB is equal to 6 degrees in its size. So according to the law of cosines, in this right triangle CPB, the following equation is true. CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. Okay, again, in this right triangle CPB, according to the law of cosines, the following equation is true. CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. CB is the missing side, so we leave it as it is. CB squared equals to CP squared. CP is 12, therefore CP squared is 12 squared, that is 144. Plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16. Minus 2 times CP, that is 12. Times PB, that is 4. Times cosine 60 degrees. Cosine 60 degrees is 1/2. So we all know that CB squared equals to 144 plus 16 is 160. Here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. After cancelled 2, we'll have to only with minus 12 times 4 is minus 48. So in total CB squared equals to 160 minus 48 is 112. CB squared equals to 112. Here we take out all this equation and finally get that CB equals to the square root of 112 units in its length. This is side CB, that equals to the square root of 112 units in its length. And CB squared equals to 112. In the next step, we'll define this angle CAB as alpha, and we will implement the law of cosines on this big triangle, triangle ABC. It shows angle theta as this angle, BAC. Angle theta equals to alpha according to our choice. So in this triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. And again, in this triangle ABC, the big triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112 and it equals to CA squared. CA squared equals to 189 plus AB squared. AB in total equals to AP, that is 3, plus BB, that is 4. So in total AP equals to 3 plus 4, that is 7. Therefore AB squared equals to 7 squared, that is 49. Minus 2 times CA. CA equals to the square root of 189 times AB. AB equals to 7 times cosine alpha. So total, according to the law of cosines, in this triangle ABC, we know that 112 equals to 189 plus 49 minus 2 times the square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238. And we have here minus 2 times 7 is minus 14. So this expression in total equals to minus 14 times root of 189 times cosine alpha. So here we will subtract 112 from this equation. This side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126. And here we have minus 14 times square root of 189 times cosine alpha. So here we add to this equation 14 times square root of 189 times cosine alpha, that is to say, we move this expression to the other side of the equation, and we get that 14 times square root of 189 times cosine alpha equals to 126. So here we divide this equation by 14. So this side of the equation 14 will get cancelled, and we left only with square root of 189 times cosine alpha, while on the other side of the equation we have 126 over 14 is 9. So in total we should find out that the square root of 189 times cosine alpha equals to 9. So here we substitute 189 by 9 times 21. Times cosine alpha equals to 9. The square root of 9 is 3, so we take 9 out of the root. Inside the root we left only with 21 times cosine alpha equals to 9. Here we'll divide this equation by 3. So if 3 will get cancelled, and left only with square root of 21 times cosine alpha equals to 9 over 3 is 3. So in total we found out that the square root of 21 times cosine alpha equals to 3. So here we'll divide this equation by square root of 21. And we get this cosine alpha equals to 3 over square root of 21. So cosine alpha equals to 3 over square root of 21. Here TA is the abbreviation for trigonometric identity. We use the following trigonometric identity. That states that sinus square alpha plus cosine square alpha equals to 1. We will subtract cosine square alpha from this equation. Actually, it is very easy to see, to prove that this trigonometric identity is true, but we'll not do it in this lecture. Here we'll subtract cosine square alpha from this equation. And get that sinus square alpha equals to 1 minus cosine square alpha. Here we take a root out of the equation, and finally get that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. Cosine alpha equals to 3 over square root of 21. We will square this equation. So in this side of the equation we get cosine square alpha equals to 3 square is 9 over square root of 21 square is 21. So in total we found out that cosine square alpha equals to 9 over 21. So now we can substitute cosine square alpha in this trigonometric identity by 9 over 21. We do it now and we get that sinus alpha equals to the square root of 1 and minus cosine square alpha is 9 over 21. So sinus alpha equals to the square root of, here we multiply 1 by 21 and then we divide it by 21 in order to overcome a factor in this number. So 21 times 1 is 21 minus 9 over 21. So we have 21 minus 9 is 12 over 21. Here we divide this number, both the numerator and the denominator of this number by 3. We get that 12 over 3 is 4, over 21 over 3 is 7. So in total we found out that sinus alpha equals to the square root of 4 over 7. Here you take 4 out of the root, the square root of 4 is 2. So sinus alpha equals to 2, and inside the root we left only with 7. So in total we found out that sinus alpha equals to 2 over square root of 7. Sinus alpha equals to 2 over square root of 7. We already found out that AB equals to the square root of 112 units in its length. It is CB. CB equals to the square root of 112 units in its length. In the next step, we will implement the law of sines on this big triangle ABC. Actually, the law of sines has two versions. The first version is that if we have this triangle ABC, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C. The full version is that if we have triangle ABC that is described by this circle, if we reduce R, then the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So if it again we have, this is triangle ABC that could be any triangle. This is angle BAC equals to capital A degrees inside according to our definition. This is angle ACB, it is equals to capital C degrees. This is angle ABC, it is equals to capital B degrees inside according to our definition. And this circle blocks triangle ABC, and the radius of this circle is R. Triangle ABC is inscribed by this circle. So according to the full version of the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. But again, according to the full version of the law of sides, in this triangle ABC that could be any triangle, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we'll implement the law of sides in its full version in triangle ABC. Triangle ABC is blocked by this circle. Why triangle ABC is blocked by this circle? Because of the fact that all the three vertices A, B, and C lie on the circle itself. Therefore, triangle ABC is blocked by this circle. Triangle ABC is inscribed by this circle. Therefore, we can implement here the law of sides in its full version. According to the law of sides, in this triangle ABC, the following equation is 2. CB over sinus alpha equals to 2R. And R is the radius of this circle that blocks triangle ABC. That is the radius that we are looking for this question. So CB is equals to the square of 412 units. It's then over sinus alpha. Sinus alpha equals to 2 over square root of 7. And it is equals to 2R. R is the radius of the circle that blocks triangle ABC. So today we found out that according to the law of sides, the big triangle ABC, the following equation is 2. Square root of 112 over 1 over 2 over square root of 7 equals to 2R. Here we will substitute 112 by 16 times 7. Over 1 over 2 over square root of 7 equals to 2R. The square root of 16 is 4, so we take 16 out of the root. Inside the root we left only 7, so it is this expression in total equals to 4 times square root of 7 over 1 over 2 over square root of 7 equals to 2R. So here we remove square root of 7 to the numerator and 2 to the denominator, and we get that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2, so this expression in total equals to 2 times square root of 7 times square root of 7, that's actually 7. So in total we found out that 2 times 7 equals to 2R. Here we divide this equation by 2, so we get that R equals to 7 units in its term. So if we found out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 7 units in its length. So we finish with the first question. In the next step, I will present you the second question and answer the second question of this lecture. In the second question, our task is to find out the area of this semicircle APQB. So in the drawing we have a semicircle. So again, in the drawing we have a semicircle. This is 97 PQ, that is equals to 16 units in itself. This is 97 PC, that is equals to 21 units in itself. This is angle CPQ, that is the right angle. This is the short 97 AC, that is equals to 7 units in itself. Again, our task is to find out the area of this semicircle APQB. So first of all, we'll define the radius of this semicircle as x. If the radius is x, then the diameter AB is 2x. AB is the diameter of the semicircle. Is equals to 2x units in its length. What is the length of this 97 CB? From the drawing it is very easy to see that CB in total equals to AB minus AC. Write it down. CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is 7, according to what is given as the question. So in total, we should find out that CB equals to 2x minus 7 units in its length. This is 97 CB, that is equals to 2x minus 7 units in its length. In the next step, we'll complete this semicircle to a circle. And we'll extend last one PC by straight line until it touches the circle. We will define the touching point of the extended last one PC with this circle. This point is point M. Likewise, we will define the short last one CM. This last one SA. So here we can implement rule 65 in our drawing. I pinch clicking on rule 65. First of all, rule 65 is true in any circle. This circle could be any circle. So according to rule 65, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 65 in our drawing. One put in our drawing. This is chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So all the requirements of Rule 65 are satisfied, and therefore we can implement here Rule 65. So it is on. Chord AB intersects with chord PM at point C. The intersection point of chord AB with chord PM occurs at point C. So again, now original drawing. Chord AB intersects with chord PM at point C. And therefore, according to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. Okay, again, according to rule 65, the following equation is true. AC times CB equals to PC times CM. AC is 7 times CB. CB is 2x minus 7. And it is equals to PC. PC is 21 times CM. CM is A. So in total, according to rule 65, we actually found out that 7 times 2x minus 7 equals to 21A. Here we will divide this equation by 7. So here 7 will get cancelled and left only with 2x minus 7 in this side of the equation. While on the other side of the equation we have 21 over 7 is 3, so this equation equals to 3A. So in total we found out that 2x minus 7 equals to 3A. Here we add 7 to this equation and get that 2x equals to 3a plus 7. In the next step, we will join points Q and M together by straight line. By joining points Q and M, we created the green right triangle QPM. This is the green right triangle QPM. This is peripherical MPQ. That's equals to 90 degrees in size. Peripherical MPQ equals to 90 degrees in size. And it's subtend on chord QM. Again, peripherical MPQ subtend on this chord called QM. And whenever you have a peripherical that's equals to 90 degrees in size, you can implement rule 5. So repeat quickly rule 5. According to rule 5, any peripherical that's equals to 90 degrees in its size must subtend on the diameter of the circle. In the drawing, we have a circle. This is peripherical MAN. That is equals to 90 degrees in size, and therefore it must subtend on the diameter of the circle. And indeed, peripherical MAN subtend on chord MN, that is the diameter of the circle. So according to this rule, rule 5, any peripherical that is equals to 90 degrees in size must subtend on the diameter of the circle. You can definitely implement rule 5 in our drawing. This is peripherical MPQ, that is equals to 90 degrees in size, and therefore it must subtend on the diameter of the circle. Peripherical MPQ subtend on chord QM, and therefore according to rule 5, chord QM must be the diameter of this circle. Well, you know, this is chord QM, that is the diameter of this circle according to rule 5. The radius of this circle is x, therefore the diameter is 2x. So the diameter QM equals to 2x units in its length. So in the next step, we will implement the Pythagoras theorem on this great right triangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the permission for Pythagoras theorem. So in this right great triangle PQM, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. So it is now QM squared, that is the square of the hypotenuse, must be equal to PQ squared plus PM squared. And again, this great triangle PQM, according to the Pythagoras theorem, QM squared equals to PQ squared plus PM squared. QM is 2x, and therefore QM squared is 2x squared. And it is equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. Plus PM squared. PM in total equals to PC, that is 21, plus CM, that is A. So total PM equals to 21 plus A. Therefore PM squared equals to 21 plus A squared. So in total, we found out that 2x squared equals to 256 plus 21 plus A squared. We already found out that 2x equals to 3a plus 7. So we substitute here 2x in this equation by 3a plus 7. If 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. And it equals to 256 plus 21 plus 8 squared. Here we'll open the brackets on both sides of this equation, and you get that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a is 6a, and 6a times 7 is 42a. And this equals to 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21, that is 42, times a. This is plus 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. After cancelled 42a, this side of the equation we left only with 9a squared plus 49, while on the other side of the equation we left with 256 plus 441 is 697 plus a squared. So here we subtract a squared from this equation, and you get that 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we subtract 49 from this equation, and you get that 8a squared equals to 697 minus 697 minus 49 equals to 648. Here we divide this equation by 8. 8 squared over 8 is a squared, equals to 648 over 8 is 81. So in total, if you want to know that a squared equals to 81, here we take a root out of this equation and finally get that a equals to the square root of 81, that is 9. So a equals to 9 units in its name. Yet we already found out that 2x equals to 3a plus 7. So copy this equation here. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total, if you want to know that 2x equals to 34. Here we divide this equation by 2. And finally get that x equals to 34 over 2 is 17. X equals to 17 is inside. Actually, x is the radius of this semicircle, and it's equals to 17 units inside. So x equals to 17. And our test is to find out the area of this semicircle APQB. So here we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. And therefore, the area of our semicircle must be equal to pi over 2 times the radius of our semicircle. The radius of our semicircle is x. And the radius squared is x squared. So in total, if you know that the area of our semicircle must be equal to pi x squared over 2. So it is pi over 2, and x is 17, therefore x squared is 17 squared. So in total, if you know that the area of our semicircle must be equal to pi over 2 times 17 squared, it therefore equals to 289 pi over 2 squared in size, or in terms of numbers, it equals to 453.96 square units in its size. Okay, again, if you found out that the area of this semicircle APQB, that is the area that we're looking for in this question, it is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. So, finish with the second question. The next step of the lecture, that is to say, we repeat on the solution of the first question, and then we repeat on the solution of this second question. In the first question, our task was to find out the radius of this circle. So in the drawing, we have a circle. This is line segment CP, this is equals to 12 units in itself. This is line segment AP, this is equals to 4 units in itself. This is line segment PB, this is equals to 4 units in itself. This is again CPB, this is equals to 60 degrees in size. Again, our task is to find out the radius of this circle. So first of all, it is given us the question that AB is the straight line. So if you focus on the upper side of this straight line AB at point P, here the sum of the areas must be equal to 180 degrees according to all three. All three said that the sum of the areas on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have this that equals to 60 degrees inside, plus this missing angle, in total the sum of those triangles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 120 degrees inside. This is the missing angle, APC, that must be equal to 120 degrees inside according to all three. The next step, we join point C and A together by straight line, and join point C and B together by straight line. By doing those constructions, we get three triangles. The green triangle, ACP, the white triangle, CPB, the big triangle, ABC, that consists of those two smaller triangles. So in the next step, we implemented the law of cosines on all those three triangles. So a bit tricky on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC. This is triangle ABC that could be any triangle. This is angle BAC that is equal to 30 degrees in its size. This is side AB that is equal to 8 in its length. This is side AB that is equal to 8 in its length. This is side AC that is equal to B units in its length. This is side BC that is equal to 3 units in its length. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So first of all, we implemented the law of cosines in this red triangle CAP. We choose angle theta, this angle APC, is equals to 120 degrees in size. So according to the law of cosines, in this green triangle CAP, the following equation is to CA squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. Okay, again, this green triangle ACP, according to the law of cosines, the following equation is to CA squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we will test it. So it is CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9, plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. So in total we found out that CA squared equals to 9 plus 144 minus 2 times AP, that is 3, times PC, that is 12. So in total it is minus 2 times 3 times 12 times cosine 120 degrees. Cosine 120 degrees is 1 now. So in total we found out that 9 plus 140, CA squared equals to 9 plus 144, that is 153. Here we have minus times minus is plus, so this expression is a positive expression. We have 2 in the denominator, 2 in the denominator, so 2 gets cancelled. After cancel 2, we have only with 3 times 12, that is 36. In total, this expression equals to plus 36. So CA squared equals to 153 plus 36, that is 189. CA squared equals to 189. Here we took a root out of this equation. We found out that CA equals to the square root of 189 units in its length. This is the missing side CA. This equals to the square root of 189 units in itself, and CA squared equals to 189. Likewise, we implemented the law of cosines in this right triangle CPB. Choose angle theta, this angle. CPB is equals to 60 degrees in its size. So according to the law of cosines, in this right triangle CPB, the following equation is to CB squared equals to CP squared plus PB squared minus 2 times PC times PB times cosine 60 degrees. Okay, again, in this right triangle CPB, according to the law of cosines, the following equation is to CB squared equals to CB squared equals to CP squared plus PB squared. And again, CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. CB is the missing side, so we will test it. So it is CB squared equals to CP squared. CP is 12, therefore CP squared is 12 squared, that is CP squared is 12 squared, that is 144. plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16. Minus 2 times CP, that is 12, times PB, that is 4, times cosine 60 degrees. Cosine 60 degrees is 1 half. So total, if you want to know that CB squared equals to 144 plus 16 minus 2 times 12 times 4 times 1 half. So CB squared equals to 144 plus 16 is 160. Here we have 2 in the numerator, 2 in the denominator, so 2 get cancelled, and we left only with minus 12 times 4, that is minus 48. So CB squared equals to 160 minus 48, that is 112. CB squared equals to 112. We took out this equation, and we should find out that CB equals to the square root of 112 units in itself. Repeat again. CB equals to the square root of 112 units in itself, and CB squared equals to 112. The next step, we define this angle BAC is alpha, and we implemented the Pythagoras theorem, implemented the law of cosines on this big triangle ABC. So we choose angle theta in the equation of the law of cosines as this angle CAB, this equals to alpha. So according to the law of cosines, in this triangle ABC, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. And again, this big triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112, and it is equals to CA squared. CA squared equals to 189, minus 2 times CA, that is square root of 189, times AB. AB is AP, that is 3, plus PB, that is 4, so in total AB equals to 3 plus 4, that is 7. And therefore AB squared equals to 7 squared, that is 49. And we have also minus 2 times CA, that is square root of 189, times AB, that is 7, times cosine alpha. So in total, if you want to know that 112 equals to 189 plus 49, minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238, minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 times cosine alpha. So here we subtracted 112 from this equation. So this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we have 238 minus 112 is 126, minus 14 times square root of 189 times cosine alpha. So here we added 14 times square root of 189 times cosine alpha to this equation, that is to say we move this expression to the other side of the equation. In total, if you want to know that 14 times square root of 189 times cosine alpha equals to 126. Here we divided this equation by 14, so here 14 gets cancelled. So in this side of the equation we have only with square root of 189 times cosine alpha, while on the other side of the equation we have 126 over 14 is 9. So total, if we found out the square root of 189 times cosine alpha equals to 9. Here we substituted 189 by 9 times 21 times cosine alpha equals to 9. The square root of 9 is 3, so we took 9 out of the root, so inside the root we left only with 21. So this expression in total equals to 3 times square root of 21 times cosine alpha equals to 9. Here we divided this equation by 3, so here 3 will get cancelled, and we left only with square root of 21 times cosine alpha equals to 9 over 3 is 3. So in total, if you found out that the square root of 21 times cosine alpha equals to 3. Here we divided this equation by square root of 21, and finally found out that cosine alpha equals to 3 or square root of 21. Repeat again. We found out that cosine alpha equals to 3 over square root of 21. Here TA is a version for trigonometric identity. we have the trigonometric identity that said that sine square alpha plus cosine square alpha equals to 1. It is very easy to prove that this trigonometric identity is true, but we'll now do it in this lecture. Here we subtracted cosine square alpha from this equation. If we found out that sine square alpha equals to 1 minus cosine square alpha. Here we took out of this equation. If I found out that sine square alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 4 over square root of 21. Cosine alpha equals to 4 over square root of 21. Here we squared this equation. So in this side of the equation we have cosine square alpha, and on the other side of the equation we have 3 squared, that is 9, over square root of 21 squared, that is 21. So in total we actually found out that cosine square alpha equals to 9 over 21. Therefore, we can substitute cosine square alpha in this trigonometric identity by 9 over 21. We did it, and we found out that sine square alpha equals to the square root of 1 minus 9 over 21. Here we multiply 1 by 21, and then we divide it by 21 in order to have a common factor with this number. So sine alpha equals to 1 times 21 is 21, divided by 21. We multiply it by 21, and then we divide it by 21, so we change nothing. It is allowable to multiply anything by 1. So therefore we have here 21 minus 9 over 21. 21 minus 9 is 12, and the denominator we have 21. Here we divided both the numerator and the denominator of this number by 3. 12 over 3 is 4, and 21 over 3 is 7. So in total, if you wonder, the sine alpha equals to the square root of 4 over 7. Here we took 4 out of the root, the square root of 4 is 2, so inside the root we left only with 7. So sine alpha equals to 2 over square root of 7. And then again, we found out that sine alpha equals to 2 over square root of 7, and CB equals to the square root of 112, and it's in itself. In the next step, implemented the law of size in this big triangle ABC. Implemented the law of size in its full version, because the law of size has 2 versions, the short version and the long version, the full version. The short version is about triangle ABC that could be any triangle without a circle. And according to the short version, in this triangle ABC that could be any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. The full version is about a triangle ABC that could be any triangle that is described by this circle. The radius of this circle is R. So here we have a triangle ABC. This is angle BAC, this is equal to A degrees inside. This is angle ABC, this is equal to B degrees inside. Capital B degrees inside. This is angle ACB, this is equal to capital C degrees inside. And this is side AB equals to 3 units in itself, side AC equals to B units in itself, side BC equals to 1 unit in itself. And R is the radius of this circle that blocks triangle ABC. So according to the law of size in its full version, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that draws triangle ABC. But again, according to the law of size in its full version, A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of size in its full version. Now, drawing this triangle ABC. This is triangle ABC. Triangle ABC is inscribed by this circle. Why? Because of the fact that all the 3 vertices A, B, and C lie on the circle, therefore triangle ABC is inscribed by this circle. Therefore, we can implement the law of size in this triangle ABC in its full version. Again, that according to the law of size in its full version, CB over sinus alpha equals to 2R. And R is the radius of this circle that draws triangle ABC. R is the radius of the circle that we are looking for in this question. So according to the law of size in its full version, CB of sinus alpha equals to 2R. We only found out that CB equals to the square root of 112, where sinus alpha equals 2 over square root of 7 equals to 2R. Here we substitute 112 by 16 times 7 over 1 over 2 over square root of 7 equals to 2R. We took 16 out of the root, the root of 16 is 4, so inside the root we left only 7. So it is 4 times root of 7, or 2 is root of 7, equals to 2r. Here we moved root of 7 to the numerator, to the denominator. Actually found out in total that 4 times root of 7 times root of 7 over 2 equals to 2r. Square root of 7 times root of 7 is 7, so this expression in total equals to 2. Here 4 over 2 is 2, so this expression equals to 2 times root of 7 times root of 7. But square root of 7 times root of 7 is 7. So total, this expression equals to 2 times 7 equals to 2r. Here we divided this equation by 2, and we found out that the radius of this circle, that is the radius that we are looking for this, that is the radius that we are looking for this question, is equal to 7 units in itself. So we finished to repeat on the first question. The next step, I repeat on the solution of the second question. The second question, our task is to find out the area of this semicircle APQB. So in the drawing semicircle, this is line segment PC, this is equals to 21 units in itself. This is line segment PQ, this is equals to 16 units in itself. This is the short line segment AC, this is equals to 7 units in itself. This is angle CPQ, this is the right angle. Again, our task was to find out the area of this semicircle APQB. So first of all, we define the radius of this semicircle as x. Okay. If the radius of this semicircle is x, it means that the diameter AB is 2x. This I said CB equals to AB minus AC. That is to say, AB is 2x minus AC is 7. So again, CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is 7. So in total we found out that CB equals to 2x minus 7 units in itself. In the next step, we completed this semicircle to a circle. Then we extended line segment PC by a straight line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. In the next step, we implemented all 65 in our drawing. And likewise, we defined the length of this short line segment CMSA. So in the next step, we implemented all 65 in our drawing. Let's pick up all 65. All 65 is drawn in any circle, so in any circle, if chord AB intersects with chord CD at point O, then the following equation is to AO times OB equals to CO times OD. So in the drawing we have a circle, this is chord AB that intersects with chord CD at point O. So whenever you have two chords that intersect with each other inside the circle, the following equation will be true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement all 65 in our drawing. One put in our drawing. This is called AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. Chord AB intersects with chord PM at point C. So all the requirements for chord 65 are satisfied, and therefore we can implement chord 65 in our drawing. According to rule 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. This equation is the implementation of rule 65 in our drawing. AC is 7 times CB is 2x minus 7, and it is equals to PC, that is 21, times cm, that is a. So in total, if you found out that the following to 65, the following equation is to 7 times 2x minus 7 equals to 21a. Here we divided this equation by 7. So here 7 get cancelled, left only 2x minus 7 this side of the equation. But on the other side of the equation, 23 over 7 is 3, so this side of the equation, we have in total 3a. So total, if you found out that 2x minus 7 equals to 3a. Here we added 7 to this equation, and finally found out that 2x equals to 3a plus 7. In the next step, we join points Q and M together by start line. And by joining points Q and M, we created the gain triangle, MPQ. This is peritriangle MPQ. That is equals to 90 degrees inside. Peritriangle MPQ subtend of chord QM. And therefore, whenever we have a peritriangle that is equal to 90 degrees inside, we can implement rule 5. Repeat quickly rule 5. Only to rule 5, any peritriangle that is equal to 90 degrees inside must subtend of the diameter of the circle. So the drawing circle, this is peritriangle MAN. That is equal to 90 degrees inside, and therefore according to this rule 5, it must subtend of the diameter of the circle. And indeed, peritriangle MAN subtend of chord MN, that is the diameter of this circle. So according to this rule 5, any peritriangle is equal to 90 degrees inside must subtend of the diameter of the circle. We can definitely implement rule 5 in our drawing. Because in our drawing, this is peritriangle MPQ. That is equal to 90 degrees inside. Therefore, according to rule 5, it must subtend on the diameter of the circle. Peritriangle MPQ subtend on chord QM, and therefore, according to rule 5, chord QM must be the diameter of the circle. The radius of this circle is x, therefore the diameter QM is 2x. The next step, we implement Butterworth's theorem on this grain triangle PQM. According to the Butterworth's theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. And again, according to the Butterworth's theorem, the grain right triangle PQM, the following equation is for QM squared equals to PQ squared plus PM squared. QM is 2x, therefore QM squared is 2x squared, and it is equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, plus PM squared. PM in total is PC, that is 21, plus CM, that is 8. So in total PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, if you found out that according to the theorem, the grain triangle PQM, 2x squared, QM squared equals to PQ squared plus PM squared. QM is 2x, therefore QM squared is 2x squared. And it equals to PQ. PQ is 16, therefore PQ squared is 16 squared, that is 256, plus PM squared. PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, I should find out that 2x squared equals to 256 plus 21 plus 8 squared. We already found out that 2x equals to 3 plus 7. So we substitute 2x in this equation by 3 plus 7. If 2x is 3 plus 7, it means that 2x squared equals to 3 plus 7 squared, and it equals to 256 plus 21 plus 8 squared. Here we open the brackets on both sides of this equation. So we found out that the 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a is 6a, and 6a times 7 is 42a, and it is equals to 256 plus 8, 21 plus 8 squared. 21 plus 8 squared equals to 21 squared, that is 441, plus 8 squared, plus 2 times 21 times 8, 2 times 21 is 42 times 8. So it is plus 42a. Here we have 42a on both sides of this equation, so 42a gets cancelled. After cancelled 42a, in this side of the equation we have only 9a squared plus 49, while on the other side of the equation we have 256 plus 441 is 697 plus a squared. The total if you want that 9a squared plus 49 equals to 697 plus a squared. Here we subtracted a squared from this equation, and finally found out that 9a squared minus a squared equals to 8a squared plus 49 equals to 697. Here we subtracted 49 from this equation, and finally found out that 8a squared equals to 697 minus 48 is 648. Again, 697 minus 49 is 648. So in total, we found out that 8a squared equals to 648. Here we divided this equation by 8, and we found out that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we took root of this equation, and we found out that a equals to the square root of 81, that is 9. A equals to 9. We found out that 2x equals to 3a plus 7, so I put this equation here. 2x equals to 3a plus 7, so 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27, plus 7, 27 plus 7 is 34, so 2x equals to 34. Here we divided this equation by 2, and we found out that x equals to 34 over 2, that is 17. That is to say, the radius of this semicircle x equals to 17 units in itself. Our task is to find out the area of this semicircle a PQB. Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of our semicircle must be equal to pi times the radius of our circle squared over 2. The radius of our semicircle is x, therefore the radius squared is x squared. Therefore, the area of our semicircle must be equal to pi x squared over 2. X is 17, therefore x squared is 17 squared. So in total, the area of our semicircle must be equal to pi times 17 squared over 2. 17 squared is 289, so in total this expression equals to 289 pi over 2 square units in size. In terms of numbers, it equals to 453.96 square units in size. So in total, we should find out that the area of this semicircle, that is the area that we are looking for in this equation, is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. Okay, thank you very much.